program today. Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. Welcome to today's webinar, Achieving Research Objective Through Various Data Analysis Technique. First, let me introduce myself. My name is Faris, a graduate student and one of committee from Club Pasca Siswaza, CAPSIS, FPTB, UTHM. My team and I will be responsible for hosting this data analysis webinar today. On behalf of CAPSIS, I would like to welcome our outstanding speaker, Associate Professor Technologist Dr. Lai Chi Sern, the committee of CAPSIS, and all our lovely participants. Welcome everyone. We are delighted to host you this morning as we are dedicated to support all graduate students. We hope that our program today will give you a valuable insight on data analysis and how to achieve our research objective through various data analysis techniques. A brief background of our outstanding speaker, Associate Professor Technologist Dr. Lai Chi Sern. He is a head of Department of Research, Innovation and Consultation, Malaysia Research Institute for Vocational Education and Training, MyReVET, major in Doctor of Philosophy, Engineering Education from Bremen University. Now, without further ado, Dr. Lai, the floor is yours.
Good morning, Chairperson. So today I'm going to talk about how are we going to achieve the research objective through various analysis techniques. So a little bit about my backgrounds. I graduated from the University of Bremen in Germany. So my PhD project was quantitative in nature, okay, because I did experimental research and a very small component of qualitative element because I interviewed some students during my experiment. So, and I also, when I back from Germany in 2010, I started to teach statistics for educational research for postgraduate level, master and PhD. And I stopped teaching the subject in 2017 because we are facing lack of this lecturer in mechanical panel. I have to teach a mechanical engineering subject, so I have to give up statistics. But the knowledge of statistics is still in my mind. So I think I have enough knowledge to provide you some information about quantitative data analysis. So for the purpose of today's talk, is my voice clear?
Yes, Doctor, I can hear you clearly.
Okay, good. All right. Okay. So the focus of my talk today will be quantitative data analysis. So although I conduct several research projects that involve qualitative data analysis, but I'm not going to talk about it. Just a little bit introduction about it. So I would like to know some of your background also. So ladies and gentlemen, have you developed your proposal or have you collected your data? So for those who have already conduct data collection, can you type 1 in the chat box? Okay, so there are quite a number that have already collected data. So for those who are still in the proposal development phase, can you type 2? So if you are still doing your proposal, so just type 2, let me know what is your progress. So for those who just register as a new PhD or master candidate in UTHM, can you type 3? You know nothing about research yet. You are still doing the basic reading. So for the newbie, can you type 3? Okay, so there are 1 newbie here. All right, so many are still developing proposal and some have already collected data. Okay, good. So now I have some basic idea about the audience now. Okay. So when you have already collected data, the data that we have at hand is very messy, right? So let's say you do, you distribute questionnaire. My slide is not moving. All right. Okay, so after you have collected data, you have a lot of data at hand, and the data are very messy in your computer, in your SPSS. Once you have already key in the data in the SPSS or the software that manage your data. So, and it is not in a good form. It's very messy. So we have to summarize the data. We have to organize the data so that we can understand the data. Okay. So, and the process of summarizing the data, the process of reorganizing the data is called data analysis. Okay. So, and apart from that, we have to do some analysis. So we have to find out what the data tell us, right? So these processes are included. These processes are included. It's included in data analysis. So what is data? Data is actually the information that we gather, okay, from the sources related to our topic of research, of course. So if you conduct interview in your research, so the data, okay, the interview, the data from the interview that you have at hand is considered as data. If you conduct observation, you go to the school, you look at the student, and you capture the photo, the video. So the photo and the video and the videos are your data. Okay, so basically we have two types of data. One is qualitative and the other one is quantitative. So the analysis can be divided into qualitative data analysis and quantitative data analysis as well. So how can we conduct or how can we collect qualitative data? This is a brief introduction about qualitative data. So we can collect qualitative data from interview. We conduct interview either through face-to-face, and we also can conduct interview through telephone, all right? So it doesn't mean that we have to conduct face-to-face. We can use technology nowadays. So we even can conduct interview through Google Meet, Zoom, whatever platform that we have, right, to make our life easier. We also can conduct observation, right? So we conduct observation can be conducted through our own. We go to the field. Let's say I want to conduct observation in a shopping mall. So I can go to the shopping mall and look around, see what I want to see, okay, according to my research objective, right? And also can put a camera in the shopping mall. I capture the video. So after that, I go back home, I take the video and look at the video, right? That is also a form of observation. And then we also can collect data to document printed or non-printed material. For example, report. So we have country report, annual country report. We have a bank annual report. We have report from the Ministry of Education and NGO and anywhere. So those documents can be used as a source of data, right? So we call it document, right? And other resources of qualitative data are artifact. You know, for those who do historical research, so they study the artifact, right? So the audio, video, photo, whatever, okay, anything that cannot be numbered can be used as a qualitative data. So when we have all this data, we have to analyze, because we do know what this data tell us. So until we analyze the data, so after we analyze the data, then we know what are the data tell us. So there are many ways of doing qualitative data analysis. The most common one is thematic analysis. So in thematic analysis, you have to do the coding and start with open coding. So you code what the people say, and then you do the Excel coding. Okay, and finally, you have to do the selective coding. All right. So I'm not going to talk about this in detail because if you want to talk about this. I'm quite familiar with thematic analysis because I've done several projects using thematic analysis. So the purpose of thematic analysis is to come up with the theme, the final theme that represent what you want to find out for your research. So sometimes you don't want to find a theme. It's not my objective. I just want to understand or want to capture what people said. Okay, let's say I have an interview with the Prime Minister of Malaysia. So I don't want to find out the theme. I just want to know what is the point. What is the main point from the Prime Minister? So I just do the coding or content analysis. This will be easier because the process is shorter compared with thematic analysis, right? And then we also have grounded theory. Grounded theory means that we produce explanation from a case study, okay, or from several cases study, all right? So the explanation of the justification will be refined from time to time, until we come to the point that the explanation can be used to explain every cases. So if the justification and explanation can be used to explain every cases that we study, it means that the explanation can be used as a theory, okay? And we call it grounded theory. Okay? So ladies and gentlemen, if you don't understand, you can always, or if I'm going too fast, you are confused in certain point that I mentioned, you can always interrupt me. All right, so this is an interactive session. Don't make it too formal, right? So, and now due to technology advancement, so now we have desktop analysis as well. For example, sometimes we study about the website from the Ministry of Education. We study the website from ILO, International Labour Organization. We study about the website, we capture information from the website of WHO, UNESCO, UNIWOC, where else? Ministry of Human Resource. All right, they don't have printed material, but I just study the website, what is the content of the website, and then I capture. So this is what we call desktop analysis. I look at my desktop, you know, my laptop. I just study the website, the homepage. I capture the information, and this is a new technique of data analysis, right? Desktop analysis. So for those who do qualitative research, desktop analysis is quite useful for you due to, you know, pandemic and the information in several well-known websites. All right. Okay, next we move on to quantitative data. So this will be the focus of my talk of today. So how can we capture quantitative data? First and foremost, the most common one is through questionnaire. Right, we have items in questionnaire, and through the questionnaire, you know, the respondent capture the data, answer the questionnaire, and then we capture the data. Okay, I don't think everybody have problem about this one. And then we also can have a test, examination to collect data. I want to know whether or not the student perform or achieve in mathematics. How do I know? I cannot interview them, right? I cannot ask them, do you understand? Because if they say yes, I'm not sure whether or not they really understand or not. So the best way to prove they understand or not is through examination or test or assessment. So this is another way of collecting quantitative data, because the data that we capture is in number, okay? It's not in a word form, it's in number. And then we also can capture the data, quantitative data, from secondary data. What is secondary data? Secondary data means the data already exists and we don't have to create an instrument to collect the data. For example, I want to know the achievement of SPM student. Do I have to create a test for the Form 5 student to do the to capture the achievement? No, right? Because SPM achievement already, the data for SPM result already captured, is already available in MPM. The Malaysian Examination Council is there. You just go there and capture the data, get the data. For example, I want to know the salary of a technician in Malaysia in the field of construction. Okay, so you can actually capture the data from the Ministry of Human Resource. They have the data already. I want to know the share market, the share prices. So you can go to the Bursa Saham Malaysia to get the data. So these available, readily available data is considered as secondary data. It's already there. You just go there and take it. You don't have to create an instrument to capture the data. All right. Can I use it for my PhD? Yes, of course, you can use it for my PhD. Right. For example, I want to know whether or not the motivation is related with CPGA of the student. CGPA of the student can be get from the university, right? The academic management office. You can go there and get it. So that is considered as secondary data, right? So others is quantifying qualitative data. We have sometimes we got the qualitative data. So I want to convert it to quantitative data. Is it possible? Can I do so? Yes, you can do so. For example, I conduct observation. I want to see whether or not student talk in class, student communicate in class. So I go to the class and observe the student, and I see whether or not students are talking each other. So if they talk to each other, if A talk with B, okay, I counted as 1. If A talk to C, I counted as 2. If A talk to B 2 times, I counted 2 times. Okay, so what I did is qualitative, right? Observation. But what I recorded is quantitative. So this is how we do quantifications of qualitative data. We quantify the qualitative data. And this, you have to pay attention because some researcher, some hardcore qualitative researcher, they cannot accept this. They say, you are against the philosophy of qualitative research. When we do qualitative research, we throw away number. We don't want numbers. All right. So we have to analyze it quantitatively. We don't want quantitatively. But for some other researchers, they are fine with it. They say, okay, it's not a problem to quantify qualitative data. All right. So it depends on the school of thought. So this one you have to be very careful. Huh? All right. So next, so when we want to do a quantitative data analysis, we capture quantitative data. There are several things that we must know, which is the level of measurement. Measurement means data collection. We collect data means we measure data, right? So there are 4 levels of measurement. Now this is very important because it influences the way you analyze your data, right? So the first level is nominal. Okay, so if you have experience in answering questionnaire, I'm sure you the first part of the questionnaire is usually, I'm sure you're aware that the first part of the questionnaire is usually regarded demographic data. Demographic data, usually they ask your age, where are you from? Are you from Penang, Kuala Lumpur? Your level of education, maybe, okay? And your gender, are you male or female? So this is a categorical data. They want to categorize you, whether you are female or male, whether you are from Johor, you are from KL, or you are from Pulau Pinang, right? So whether you are PhD level, master level, degree level, or school education level. So these are categorical data, and we name it as nominal data. Okay, so it's a qualitative data, right? And then secondly, we have ordinal. Ordinal can be category and can be ranked variable. Okay, so usually in a questionnaire, we are asked to choose whether or not we agree with something. One is disagree, totally disagree, 2 disagree, 3 agree, and 4 fully agree. So this is a rank order, and we call it ordinal data, right? And another example of ordinal data is I want you to rank your lecturer, your supervisor from 1 to 10. 1 is very bad, 10 is very good. So you rank your supervisor. So you can rank it as 1, okay, you can rank it at 5, and you can rank your supervisor as 9. So this type of data also considered as ordinal because it's a ranking data, right? And then the third one is interval. So interval means that the data can be put in interval. For example, for example, your test score, okay, 1 to 10, 11 to 20, 21 to 30. So this interval is consistent and is understandable, right? And ratio, the difference between interval and ratio is that ratio has absolute 0, and interval, there's no absolute 0. What does it mean? So for interval level, 0 doesn't mean 0. Okay, what is 0 doesn't mean 0? For example, I conduct a test, mathematics test, one student got 0. What does it mean? Does it mean that the student has 0 knowledge about mathematics? No, that's not the way. So 0 means the student cannot answer the item, the question in the test, but it doesn't mean the knowledge of mathematics is 0. So 0 doesn't mean 0 in interval. All right. Another example, when you have fever, the doctor will give you a thermometer to measure your temperature, right? So let's say your temperature is 0. Let's say example is 0. Does it mean that there's no heat? It's wrong. Even it's negative degrees Celsius, there is still heat there. So 0 doesn't mean 0. All right. Another example is your IQ test. Let's say you do the IQ test and you got 0 marks. Does it mean that your IQ is 0? No. Okay. 0 means that you answer totally wrong in the question in the IQ test. Okay. So for the ratio, there is absolute 0. 0 means 0. For example, the weight of something is 0. What does it mean? It means that that thing has no weight, right? If I say the length of something is 0, what does it mean? It means the length is 0. It doesn't exist, right? So the ratio means 0. There is a 0, absolute 0. Okay, 0 means 0. So far, do you have any question about this level of measurement? Okay, I repeat, nominal means a categorization. It's for classification. Okay, whether you are female or male. So whether you are from urban school or rural school, whether you are from T20 or B40, okay, a high income or low income family. So this is nominal. It's for classification. It's for categorizations. Ordinal is about ranking. Very good, not good, good. Frequently, seldom, rarely, never. So these are ranking, right? In order, in sequence. Interval means you can put your data in interval. 1 to 10, 11 to 20, 21 to 30. What type of data can you put in interval? Age. Your age can be put in interval, right? 1 year old to 10 years old, 11 years old to 20 years old. All right. But it's age, interval, or ratio? Age is ratio because 0 means 0. If I say you are 0 years old, what does it mean? It means that you are not yet born, right? So 0 means 0. So if 0 means 0, it's ratio, it's not interval. All right. So now let's see. Nominal is category. Ordinal can be category, can be rank. So what does it mean? It can be category. For example, the scale for ordinal is first place, second place, third place, and fourth place. Okay. First ranking, second ranking, first rank, second rank, third rank, and fourth rank. Can I categorize it? I change it. First star, second star, 3-star, 4-star, and 5-star. The hotel categorized in first star. The hotel categorized in 5-star, right? So it means that the rank order can be used for category as well. right? The third one, the data from interval can be used as category, can be used for ranking, and can be used for interval or equal spacing. For example, your exam marks. Okay, so can I use this for ranking? Yes, we can use it for ranking. For example, 0 to 10 is low ranking. 11 to 20 maybe is second lower. 90 to 100 is the highest rank. It's the top rank. So based on the exam marks, I can do the ranking. And I also can do categorization. For example, those students who get 0 to 50 is low achiever. 51 to 100 is high achiever. So I already do the classification of students based on the exam marks. Two classes, low achiever and high achiever, right? So it means that test exam or examination result can be used as categorical data, can be used as rank order, and can be used as interval data. Okay. So the last one is ratio. Ratio is a very powerful data. So you can use it for categorization, ranking, interval, and true zero. Zero means zero. All right. So these are the basic idea about level of measurement, and it influences the way we analyze the data, because some statistics cannot analyze categorical data or nominal data. All right. So this one, sometimes some of the analysis cannot analyze this one, cannot analyze nominal data, and some of the analysis method cannot analyze ordinal data. They can only analyze interval or ratio data. So that's why you have to be very, very clear what type of data you have. You have interval or ordinal or nominal. All right. So next, okay, in quantitative data, we have descriptive statistic, and we also have inferential statistic, two types of statistic. Now, everybody have to use descriptive statistic. So when you do research, let's say you collect your data to 100 or 200 respondents using questionnaire, and you want to know the background of your question of your respondent, right? So let's say you have 200 respondents. All right. So you want to know your respondents' background, whether they are, how many are female, how many are male. All right. You cannot present your data using SPSS. You just show your database to the readers. They cannot understand. So you have to analyze it. You have to arrange your respondent in a well-organized form. Okay. How many people are female? 150. Only 50 are male. So you make it in a table form. So this process of summarizing your data, the process of organizing your data is called descriptive statistics. Okay. So maybe you can represent your data in a graphical way. For example, you do a bar chart, you construct a pie chart. Okay. So this graphical way is called graphical descriptive statistic. All right. And sometimes we also want to know what is the age, the mean age of my respondent. Are they very old uncle? Are they very small? Are they composed of a small child? So I want to know also the age of my respondent, right? So you just calculate the mean. Okay, so the mean also explains something about your respondent. So this is also a descriptive statistic. Why? Because the mean describes your respondent. Okay, here it is. Okay, so descriptive statistic provide you some information about your data, the basic information. What is the basic information about your data? For example, their gender, their age, and also maybe you can highlight the relationship between your data. Okay, so we can look at it one by one. We can do it using graphical method. As I said just now, your data can be grouped in a table form. You can tabulate your data. You put it in a table form. How many are female? How many are male? How old are them? what are their level of education, how many got PhD, how many got master, and how many got bachelor degree, for example. So you can present it using a graph or pie chart or any other way. Okay. So, and the example that I give you just now, mean, right? Mean is the measure of center tendency. Mean, mood, and median. Okay. For example, I want to know the income of my respondent. What is the median of income of my respondent? Some people, they earn 1,000 a month. Some people, they earn 10,000 a month. But what is the median? The center of the income. What is the value of the center of the income? Median. All right. And also the mode, the highest frequency of certain variable. So all this is considered as central tendency. And we also have measure of dispersion and the measure of association. So I have already explained this one, graphical way of descriptive statistic. Yes, so you can represent your data using histogram, scatter diagram, scatter plot, bar chart, or table. So this is to organize our data because our data is very messy, right? So this is very important for you because you usually do this for your PhD or master dissertation because you have to explain the background of your respondent. And this is very important mean. So for example, you collect data using your questionnaire. So after you collect the data, you calculate the mean, right? Okay, you calculate the mean. So mean will represent the general idea of the respondent. For example, 1 is disagree. Sorry, 2 very disagree. This one is disagree. 3 is agree. 4 is very agree. All right. So after the respondent take, some people they take 1, some people they choose 4, some people they choose 3, and you have to calculate the mean, okay, to represent the overall selections of answer from the respondent. Maybe the mean that you get is 3.5 in average. What does it mean 3.5? So 3.5 is here. So it means that majority of the respondent choose 3 and 4 between these two scale. So this is how it gives us some idea about the general idea of the respondent, the general perception of the respondent. All right. But you presenting mean is not enough. We want to see your standard deviation also, right? Standard deviation. So when you read a dissertation or journal paper, when you see mean, it's usually accompanied with standard deviation, right? Why? Because it gives you some idea about the selections of answer from the respondent. I repeat it, 1, 2, 3, and 4 from the questionnaire. You ask whether you like UTHM. Okay, 1 is disagree, very disagree. 2 is disagree. 4 is agree, and 3 is agree, and 4 is very agree. And the mean is 3.5. All right, 3.5 is here. So based on this 3.5, we don't know whether or not the the respondent choose 3 to 4. Most of them choose 3 or 4. Okay, so this value has to be accompanied with standard deviation. For example, the standard deviation is 1. 0 maybe is 0.8, cannot 0.5. So it means that the mean value, this is mean 3.5. Standard deviation is 0.5 and 0.5 plus and minus. All right, so this is 4. This will be 3. Maybe this is not a good idea. So I change it to 2.5. So 2.5 is your mean value. Okay, your standard deviation is 1. So this is positive 1 and this is negative 1. So positive 1, you add 1 here means 3.5, and this is minus 1 is 1.5. So based on this interval, I can assume that there are many respondents choose 1, 2, and 3. Okay, because the standard deviation is very big. The value for standard deviation is very big. So what does it mean? It means that the consistency of answer from the respondent is not consistent. It's very low. Okay, if you have a very small standard deviation, for example, 0.1, your standard deviation is 0.1. So your range is here, 0.1 from your mean. So this is 0.2, 0.6, and this is 0.7. So because the difference is very small, so it means that the variations of respondent answer is very small. So it means that the answer from the respondent is very consistent, either 2 or 3, 2 or 3. There's no 1 and there's no 4. So if the larger the standard deviation, the bigger the variations of answer from the respondent. It means that the consistency of answer from the respondent is very low. They are not consistent. Some choose 1, some choose 4, some choose 2 and 3. And this is not good for the research. Do you have any questions so far? So I assume you don't have. Okay, so descriptive descriptive statistic also can be used for can be used for the measure of association. It means that we want to find out the relationship between two variables. So, for example, we do the scatter plot diagram. All right. So this is your motivation, and this is your result. So and then you have you plot the data. Okay, this is your data. Okay, this is a scatter plot. So based on this data, I can see the relationship between result and motivation. The higher the motivation, the better the result. You can see the straight line here, right? The directions of your data. All right. So it means that from descriptive statistic, we also can find out the relationship between two variables, right? But this, and of course, we also can use a statistic to find out the relationship. For example, the chi-square and also the correlation analysis. Okay, so chi-square and correlation analysis can be descriptive and can be inferential statistic as well. Okay, because it can use to project the relationship for a population. Okay, I back to this one. Okay, I already explained you, provide you some explanations about descriptive statistic, and the next one is inferential statistic. Now, inferential statistic is used to predict something or to project, your analysis to a bigger population. Okay, so we correct. You know, when we do research, our target is from a population. We have a population. For example, I want to study about the motivations of doctors in Malaysia. So the doctors in Malaysia, let's say example, 20,000. Can you collect data? Can you distribute your questionnaire to 20,000 doctors in Malaysia? Cannot, right? You don't have the ability, you don't have time, and you don't have money. So you can just take a small sample, 200. Okay, so from this 200, you do the analysis. Okay, the motivation, the correlation, the relationship between motivation and job performance. All right. So the result from this 200, okay, you can be used to generalize into 20,000. So if there is a correlation from this sample, it means that there is a correlation for this 20,000 doctor. So we generalize your result from the sample into the population. So this is the statistic known as inferential statistic. Excuse me. All right. So inferential statistic can be divided into two, parametric and non-parametric. So there are some characteristics. Parametric involve interval and ratio. So this is ordinal. Sorry, this is the level of measurement. So non-parametric involve nominal and ordinal. Okay, do you still remember the level of measurement? So we have four, right? So the first one is nominal. Nominal is for categorization, is to classify respondent. Ordinal is about ranking, 1, 2, 3, 4, 5. Very disagree, agree, and very agree, right? Good, not good, and bad. So these are ranking data or ordinal data. So an interval, you can put it in interval, and ratio, there is an absolute 0. For example, your height is ratio, right? So what else? The test, the IQ score is interval, right? Your CGPA is your interval. So interval and ratio is parametric statistic. Nominal and ordinal data belongs to non-parametric statistic. So in parametric statistic, the data have to be normally distributed. So if I put it in a graph, the data have to be like this way. It's normal distribution. Okay, my drawing is not that good. All right. So, and usually it involves a key estimation from the sample, for example, mean. Usually we use mean in calculation. Okay. For non-parametric, we don't care about your distribution. Distribution free. Okay. So we don't care about your normality of your data distribution. All right. So inferential statistic can be further divided into three: univariate analysis, bivariate, and multivariate. Univariate means one variable. Bivariate means two variable. Multivariate means many variable. For PhD level or master level, you usually involve multivariate analysis. Univariate, yes, you can use it, but oh well, because you have a lot of variables, so the chances for you to use in univariate is not that high. All right, so now look at it. What is univariate analysis? It involves only one variable, okay, or only one variable is analyzed. All right. So, for example, for your PhD analysis or master analysis, you usually will check the normality of the data, whether your data is normally distributed. If you put it in a graph, will it distributed like this? Okay. So we also want to check your variance, whether or not the variance are homogeneous, are similar, okay, between different groups. So we have Levin's test and normality test and other tests. These are the two basic examples. So this is for data screening. It's not to achieve your research objective. The analysis that we use to achieve our research objective is Z-test, T-test, and ANOVA for parametric, and we also use chi-square and Mann-Whitney for non-parametric. Okay, so non-parametric means that if our data is categorical, nominal, or ordinal. So parametric means if our data is interval or ratio. Okay, or if the data is normally distributed. If it is not normally distributed, it's not normal distribution, so you have to use non-parametric. Okay. So what is Z-test? Okay, Z-test is a way to see whether or not there is a significant difference from one sample compared with the population. So when are we going to use Z-test? If we know the population's variance. Okay, if we know the population variance, and then we can use Z-test. Or sometimes we don't know the population variance, but the sample size is more than 30, so we can use Z-test as well. All right. So if we do not know the population variance and the sample size is smaller than 30, so we cannot use Z-test. What should we use? We can use T-test. All right. So what exactly is Z-test? So it's easy to look at the example. So example 1. So you want to determine whether or not the female student in FPTV, in the Faculty of Technical and Vocational Education in UTHM, score more than 60 in mathematics for the semester 2 session 2019 and 20, because we need to be specific in research, right? So you want to know whether or not the female students score higher than 60 in mathematics. So how are you going? What statistic you want to use? So you use Z-test. Why you use Z-test? Because you can find the variance. How can I find the variance? You go to look for the lecturer who teach mathematics. You get the marks for the population in the Faculty of FPTV. All right, you go to the lecturer. Okay, you get the marks. Okay, for the 156 student, and then you calculate the variance. You can do the calculation using SPSS, calculate the variance, and then you use the variance to do the Z-test. Of course, you don't have to do it manually. You can use SPSS to find out the result. Okay, so the result will tell you whether or not, in average, the female student will score higher than 60 in mathematics. Okay. Example 2, you want to find out whether or not, okay, in average, a female student of a high school in Tun Ismail High School score higher than 60 in mathematics in 2020 compared with mathematics SPM. SPM is a government examination for the Form 5 student, K-12 student in Batu Pahat district, in Batu Pahat area. All right. So in Batu Pahat, the population size for SPM student is 2,311. Can I get the variance? No, you go to the education department. Education department in Batu Pahat district, you get the variance for SPM mathematics. They cannot provide you the data because they don't calculate the variance. They only give you the mean. They say in average, the mathematics for the SPM student in 2019 is blah, 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 blah. They give you a value. All right, but they cannot give you the variance. So you don't know the variance, all right? But your sample size in Scholar in Tun Ismail High School is 87 female student. I want to know whether or not this student will score higher than 60 in mathematics in 2020. How do I know? So you can use Z-test to identify whether or not they will score higher than 60. Right? So because the sample is higher than 30, although we do know the variance, we still have to use Z-test. Remember here? Okay, if the population is larger than 30, although we don't know the variance, you can use Z-test. Okay. There are two conditions here. One, if you know the population variance, you use Z-test. If you don't know the variance, but your sample size is more than 30, you can use Z-test. Okay, one sample t-test. All right, so this is quite similar with Z-test. So when we use this one, when we use one sample Z-test, if the sample is smaller than 30, okay? If it is smaller than 30, then we don't use Z-test, we use t-test. For example, determine whether on average female electrical technician earn more than 1,800 per month. So we do know, right? So I have to study whether or not in average female electrical technician earn more than 1,800 per month. So we know that the mean salary for technician the mean salary for the population is 2,000. In average, technician earn 2,000 a month in Malaysia. Where can I get this data? I can get it from the Ministry of Human Resource. Okay, they provide this figure. Okay, but we do not know the variance of the population in Malaysia because Malaysian technicians too many. I cannot do the calculation, right? I cannot calculate the variance. So I don't have the variance. So, and too many female electrical technician in Malaysia, I cannot do the data collection for everybody. So I only take a small sample. I take 20 female electrical technician in Fujitsu, Parit Raja. Okay, I just collect data from these 20. So what method can I use? Z-test or t-test? So the answer should be, okay, there are some answer here. T-test, the answer is t-test, right? Why? Because the number of sample is smaller than 30. It's very simple, right? So now you can check your objective. For those who already collect data, see or not, see this method is relevant to your objective. Are you comparing one single sample to a population value? If yes, and then you can use either t-test or z-test. And for those developing proposal, you also can identify now whether you use one sample, z-test or t-test. Now this is univariate. Why? Because only one variable. For this case, what is the variable? The variable is salary, right? Salary is the variable, monthly salary. Okay, chi-square goodness of fit. So chi-square goodness of fit is used to see or not, it's used to determine whether or not your data, your collected data, match with the expected outcome. What is your expected outcome? Or whether or not it match with the trend that you expected. Okay, and it involves only nominal data. You see, type of data is very important because a certain method only use certain type of material. So you cannot use ordinal, you cannot use ratio and what interval unless you convert it to nominal data, and then you can use it. Otherwise, you cannot. We only use nominal data. Okay, so what does it mean? Aiming to determine a set of observed variable match with expected variable. Okay, what does it mean? It means that if you want to see, for example, Malaysia car. We have Malaysia car. Let's say Proton Saga. Okay, whether the buyer prefers certain color. So we have red color, dark color, white color, right? So, and your expected outcome is the buyers do not prefer in any color, right? So based on your based on your data collected, so you do the calculation, okay? So you have to use this method, the goodness of fit test, to see whether or not the buyers in Malaysia prefer certain color for the Malaysia car. All right, I give you another example here. So let's say a researcher is interested to find out whether secondary school leavers have higher tendency to enroll in certain TVET programs, such as do they prefer construction, do they prefer electronics, do they prefer machining or hotel management and digital design. So school leaver, you know SPM school leaver, do they have the tendency to enroll or prefer in certain program? So if you want to find out, you have to use goodness of fit. All right. So another example, the researcher is interested to find out whether UTHM graduate prefer to work in certain states, in certain states, such as Johor. Do they, the UTHM graduate, do they prefer to work in Johor, or do they prefer to work in Selangor or Penang or Terengganu or any other state? Right, you want to find out, so you can use goodness of fit. So you don't use mean, you cannot use mean to calculate this one. It's wrong, right? So another example, let's say you want to find out whether or not TVET student in KV means vocational college. The vocational college prefer to adopt certain learning style, such as visual, auditory, and kinesthetic. So the TVET student in the vocational college, do they prefer to adapt certain learning style. Do they prefer visual or do they prefer auditory or do they prefer kinesthetic? So some of the PhD candidate, they use mean. They use mean to calculate which mean is higher. If the mean in visual is higher, it means that you tell that or you conclude that the student in KV Batu Pahat prefer visual learning style. This is correct. I never say it's wrong, but this is not. It's correct but not accurate because I can argue that is it significant? Is your result significant? You only tell the mean, right? Mean there's no significancy. The mean is higher doesn't mean the result is significant. So if you want to find a significant result, you have to use statistical testing. So you have to use chi-square goodness of fit for this type of question. Okay. So ladies and gentlemen, so if you already have your research objective, now you can check whether or not your research objective fit with this context. Are you looking for a pattern? This is a pattern, right? You want to see the pattern, whether or not they prefer in something. Okay, so just now we have mentioned one sample t-test. We also have independent sample t-test on Mann-Whitney. So this is parametric. Mann-Whitney is non-parametric, but their concept is the same. All right. So parametric means that the distribution of the data is normal, right? Normal distribution. The graph should be like this. It's a normal graph. Okay. The data should be interval or ratio. All right. Let's say, okay, tell the function first, the use of this independent t-test. So it is used to determine whether there is a difference between two unrelated groups. Unrelated group means that two different groups. For example, school A and school B. School A and school B are not related, right? They are independent. So class A and class B, female and male students. So two groups are independent. Two groups are unrelated. So if I want to find out the difference between two groups, so I have to use independent t-test. All right. So there are some assumptions here, and it must be two groups. Okay, two independent unrelated group. So the data have to be interval and ratio, and the data have to be normal distribution. So if you cannot get this you don't meet this assumption. If the assumptions are not met, so you have to use Mann-Whitney. Okay, so there are some assumption or requirement. If this requirement is not met, so you have to use Mann-Whitney, especially this one. If the data is not normal, you cannot use independent t-test, so you have to use Mann-Whitney. All right. I'll give you an example. Okay, you want to find out, a researcher tries to find out whether or not the use of multimedia in teaching will bring about a positive impact on test performance. Okay, if a teacher use multimedia in teaching, will the students test performance or achievement is higher between male student and female student? Okay, so there are two groups here. One is female and one is male. So which one have higher score, test performance after using multimedia in teaching? So you want to make comparison in two groups. So you have to use independent t-test. Why independent t-test? Because these two groups are independent. They are not related. Okay. So another example. Now, ladies and gentlemen, this technique is very common in PhD and master research. So you better have to get a better understanding about this one. Okay, another example is the researcher want to investigate whether or not there is a significant difference in teaching effectiveness between technical and non-technical lecturers in UTHM. Technical lecture means those who are teaching technical subjects such as welding, cooking, construction, Non-technical means those lecturers who are teaching art subject, for example, art or science subject. For example, English communication, what else? TITAS, moral education, and so on. All right, those are non-technical lecturers. I want to make comparison between this group, non-technical and technical. Okay. So what should I use for this case? Okay, should I use independent t-test or Mann-Whitney? Okay, so 100 students, how many respondents are involved? 100 students are involved because they are asked to rank the teaching effectiveness from 1 to 5. 1 is very bad effective, 5 is perfect effectiveness for 33 technical lecturers and 29 lecturers. So ladies and gentlemen, I have a box here. So this is a new book, the cover still not yet open. Interactive PowerPoint for teachers. So this is a good reference book. So I will give it for free if you get the correct answer. Can you type your answer in the chat box? So those who get the correct answer for the first who answered correctly, you will get this book. I will pass it to Faris, and Faris will pass it to you. Any answer? Only 2 options. You can type either independent or Mann-Whitney. You make a wild guess also can, right? So let me check the answer. The first answer, the first who answered correctly, let me see. Shukri. Okay, Shukri, you get this book. Tanya, congratulations. So I will pass it to Faris. Interactive PowerPoint. So the answer is Mann-Whitney. Okay, so I had to jot it down because I'm Faris. You get this book. I still have more books. I have SPSS statistic. I give you for free if you answered it correctly. And also have statistic for educational research. All right, and we also have research in teaching and learning. All right. Okay, so the answer is Mann-Whitney. Why Mann-Whitney? All right, so now you look at the data. Okay, 100 students are asked to rank from 1 to 5. Okay, for a t-test, independent t-test, what is the type of data? Okay, the data have to be interval or ratio. If you ask student to rank something, what is that data? It's ordinal, right? Ranking. Ranking is ordinal. We ask the student to rank from 1 to 5. So 1 to 5 is ordinal. Ordinal is non-parametric. Non-parametric is Mann-Whitney. Okay? So it's not independent t-test. All right, how many groups are here? There are 2 groups, Not 1 group. Some people, they say it's only 1 group because 100 students. No, this is your respondent. So there are 2 groups here. So one is technical teacher and the other group is non-technical teacher. So there are 2 groups. So you want to compare what? What you want to compare? Effectiveness, teaching effectiveness. That is your variable. How many variables? 1 variable, right? So this is univariate. And we also have the comparison for more than 2 groups. 2 groups, we use independent t-test if we have more than 3 groups. So we use ANOVA. Now, more than 2 groups, right? Or Kuskavari. Kuskavari and ANOVA has the same concept, but ANOVA is parametric. Kuskavari test is non-parametric. The concept is the same, okay, ladies and gentlemen. So this one is we want to make comparison between 3 and more group or more than 2 group. So the group must be unrelated or independent. So there must be at least 3 group. So the data have to be racial or interval, and the data must be normally distributed, and a random sampling. Sampling must be randomly selected. So Kuskavari test is used if the data is ordinal level or the data are not normally distributed. Okay, if the distribution is not normal, so you cannot use ANOVA, you have to use Kuskavaris. All right, give you example. You want to determine whether or not students with different social economy background affect online learning performance. During the pandemic, many people do online learning, right? But some people they cannot learn through online platform because they are very poor, you know. They cannot buy they do not have a good internet access or do not have the electronic gadget. So will this economic social status affect the learning performance? Right? So how many groups that we have? So based on our independent variable, the social economic status, we divided into 3 categories. One is B40, M40, and T20. This one is bottom 40. Bottom means low income, medium income, and high income. T means top and top 20. All right, so these are the 3 categories. And then the dependent variable, the learning performance. Okay, so the online learning performance, how to measure this one? We can use exam result. All right, so I want to see if there is any difference between these 3 groups. So what can I use? So I can use ANOVA. Okay, not t-test, because t-test was 2 groups, this one 3 groups. Okay, so exam result is interval, right? Interval, so we can use ANOVA. If the result is not normally distributed, and then we cannot use ANOVA, we can use Kuskavaris. Repeated. Oh, this is actually repeat. We also have repeated ANOVA, repeated measure ANOVA or Friedman test. Repeated measure ANOVA is parametric. Friedman test is non-parametric, and they have the same concept. So for repeated ANOVA, the assumptions are interval or ratio, not ration, ratio, and normal distribution as usual. So if the assumptions are not met, then we use a Friedman test. Okay, and what is it for? What is it compared with ANOVA is the different. Okay, so ANOVA is 3 group, right? Group school A, school B, and school C. All right, is there any significant difference in terms of student achievement? So I want to compare 3 schools. This one is ANOVA. Okay, so if I have school A, all right, I want to compare if there is any difference in student achievement in 2019, 2020, and 2021. Okay, is there any difference between these 3 set of data, 3 years, 3 different years? Is there any significant? So this one, we cannot use ANOVA. Why? Because only 1 group. ANOVA has to be 3 unrelated group. 1, 2, 3, A, B, C. Repeat here. ANOVA group are unrelated or independent. See here? So if there is only 1 group and the measurement, there are 3 times or more measurement, so we have to use repeated measure ANOVA. Repeated measure, what does it mean? The measurement is repeated. Okay, 1 time measurement. We repeat the measurement in 2020, and then we repeat the measurement in 2021. So this is repeated measure. So, and we want to find the difference between these 3 set of data. So what can I use? I use repeated measure ANOVA. Okay, so if the data is not normally distributed, you don't use ANOVA, you use Friedman test. And then you may ask, where can I do this Friedman test? Or you can do it in SPSS. Okay, so for quantitative, we usually use SPSS. For qualitative, we use NVivo. This is the software. NVivo for qualitative. So this one, SPSS, is for quantitative analysis. And NVivo, it doesn't help you to analyze it. It's help you to manage your data. Because I used this before, it's very powerful. It makes your life easier because it's very easy to manage the data, but you still have to analyze on your own. Okay, NVivo. Okay, example, a teacher wants to investigate whether different teaching strategy provided better learning satisfaction to students. She applied 3 different teaching strategy in a class. So, and then, not 4, 3. Teaching strategy to 40 participants and asked them to provide satisfaction score for each strategy. So one group of students, okay, strategy A, strategy B, and strategy C. And after strategy A, they ask the student to answer the score, satisfaction score, whether they satisfied with their learning process. So after strategy B, they also ask the student, the same student, not different student, the same student, to ask them to provide the satisfaction score and also the third strategy. So how many groups are here? How many groups? 1 group. How many measurements? 3 measurements. After strategy A, we have 1 measurement. After strategy B, we have 1 measurement. After strategy C, we have 1 measurement. It's repeated 3 times. So this is repeated measure ANOVA, and we want to see the difference. All right. So if C is higher than B and A, so which strategy we have to use? So we got to use strategy C. So this is how research helps us to improve our teaching. All right. So now we move on to bivariate statistical analysis. So univariate means univariate means one variable is analyzed. Bivariate means 2 variables are analyzed. Okay, so the parametric one is Pearson correlation, simple linear regression, and pair t-test. For non-parametric, we have Spearman chi-square test of independence and Wilcoxon. Chi-square just now in I also explained in univariate chi-square goodness of fit test, right? There are many chi-square tests. Univariate one is a chi-square goodness of fit. And this one is the test of independence or the test of association. So it is for correlation. Now let's look at it one by one. What is correlation? So correlation means that we want to see whether or not there is a relationship between 2 variables. Between 2 variables. 2 variables means what? 2 variables means bivariate. So, and the data have to be the assumption. We look at the assumption. So the data has to be an interval and ratio. So it must be linearly related, and the data must be normally distributed. So these are the the score interpretation. After you do the analysis, I give you a result. They give you a coefficient. Excuse me. So after that, they give you a result. So R is the score, the maximum is 1. Either maximum is either 1 The range is 1 to -1. So maximum can be 0.99 or -0.99. So both are very strong correlation. Okay, this one is positive correlation. This one is negative correlation, which means reverse correlation. Reverse correlation means that the higher is something, the lower is something. For example, satisfaction and workload. The higher the workload, the lower the satisfaction, right? The lower the workload, the higher the satisfaction, for example. That is negative correlation. Positive correlation, your income and satisfaction. The higher the income, the higher the satisfaction. The lower the income, the lower the satisfaction. So that is positive. So the R score, it will help you to, when you have got the highest R score, the correlation. So for example, 0.58. So this is a moderate. Okay, so this range according to Evans 1996. There are a lot of reference that you can refer to. All right, give you one example. A researcher would like to determine whether there is a significant relationship between the time spent on internet and academic achievement. The time you spend on internet and the academic achievement. So you check the variable is interval or ratio. Time spent, they are ratio, right? Time you spend on internet is ratio. Academic achievement is interval. So now you can see it's either interval or ratio. Okay, so which means that it's okay. It's the requirement is met. And the second, we have to check whether or not the data is distributed normally. Okay, you do the graph in SPSS. You check the graph, or you do the test, normality test using Kolmogorov statistic. So you can check whether or not it's normally distributed. So if it is normally distributed, and then we can use Pearson to check the correlation between these two variables. Pearson. For example, the data is interval and ratio, but it is not normally distributed. So we cannot use Pearson already. What can we use? We use Spearman. All this can be done in SPSS. SPSS is very powerful. So what I explained here is very conceptual, very theoretical. So it's not a hands-on session. If you want a hands-on session, you have to do it in another session. Okay, chi-square of, for example, sometimes our data is not interval or ratio. It's not time spent. Internet, it's not about our height. For example, whether there is a correlation between your height and your weight. Weight and height is ratio, right? So we can do a Spearman. But sometimes our data is not interval and ratio, it's categorical. For example, is there any correlation between, for example, gender and is there any correlation gender and a program, study program? Is there any correlation? Study program. What is study program? For example, catering, construction, mechanical engineering, civil engineering. Is there any correlation? Maybe female prefer cooking. Maybe female prefer design, interior design. Maybe female prefer construction. Maybe male prefer mechanical engineering. Right? Is there any correlation between gender and study program? Gender is not interval. Gender is nominal. Nominal data is categorical data. Study program also nominal, right? Nominal. For example, civil engineering, electrical engineering, mechanical engineering. Nominal and nominal, we cannot use Pearson, we cannot use Spearman. So what should I use? We have another technique. We call it chi-square, test of independence or test of association. So which means that I want to know whether or not the selections of study program depends on gender or associated with gender. Is there any relationship, in other words? So we can use test of independent or test of association, the chi-square test. So we want to compare two variables to see whether they are related or not, right? So the data have to be categorical data or nominal data. They're the same thing, okay, same meaning, okay? So there must be two or more groups of each variable. Two or more group of each variable, what does it mean? For example, gender. How many group in gender? Two group, right? Male and female. Male and female. So study program, the example I given you just now, study program. How many group? It depends on you. It depends on your research objective. Let's say I have 3 groups. Mechanical engineering, electrical engineering, and civil engineering. So does it meet the requirement? At least 2, right? So it's okay. So it means that we can do the chi-square test of independence. I give you one example. A research aims to study if marital status depends on education level. Okay, so if someone married or not, does it depends on the education level? So if you have PhD, does it mean that you married or you tend to divorce? We do know, right? So we have to do the study. So we conduct a research using 300 respondents, and I check their education level and also their marital status, whether they never married, divorced, or widowed, right? And also their level of education. This data, what is this data? The data here, what is the data here? The data here is frequency. How many people have middle school and never married? There are 18 respondents never married, and their level of education is middle school. Okay, let's check widow. There are 3 respondents who are PhD holder, and they are widow. So these are frequency. So this table is called contingency table because there are 2 variables here. One is status and one is level of education. All right. So now you can check whether or not your objective need this statistic. Or you are confused. Let's say you refer to your research objective. You're confused. You don't know what to eat. You also can share with us now. Okay, so pair t-test. So pair t-test. T-test, just now we have already mentioned 2 t-tests. One is one sample t-test. It is similar with z-test, right? And the other one is independent t-test. Independent t-test means that we want to compare 2 independent groups, school A and school B, country A and country B. So that is 2 independent t-tests. Now this one is pair t-test. Pair t-test means there's only one group, single group, and we want to make comparison between 2 sets of data. One group with 2 sets of data. See here, you see the pair t-test assumption. One sample with 2 independent observation. 2 independent observation means 2 measurement. Independent measurement mean different measurement. All right. So the data have to be interval or ratio and normal distribution. If it is not normal, what should you use? You use Wilcoxon. All right. So the concept is the same. One is parameter and one is non-parameter. All right. So one group, 2 different measurement. For example, class A, school class A. I want to see whether or not problem-based learning is effective. So how I know whether problem-based learning is effective or not? After I conduct problem-based learning and then I do the test. If the test is very high, I mean the score of the tests are high, so it means that problem-based learning is very effective. If the test score is very low, it means that problem-based learning is not effective, right? So we have to see the increment. So before the class, I have to do the test. I measure first what is their score. So after I do PBL, I conduct PBL, I do the test again. So if before the PBL, the test score is 20, because before, right? Before PBL is usually very low marks. In average, the mean is 20. After the PBL, the test is 22. So is there a significant increase here? 2 only, right? So it means that, so after we do the test, there's no significant difference. There's no difference between test A and test B. We use what method to check? We use pair t-test to check, okay, to analyze. So although the mean is higher, but it doesn't mean that PBL is better, because using the pair t-test, the difference is not significant. So if it is not significant, it cannot tell you, you cannot conclude that PBL is effective, right? So after PBL, if the test score is 80, it's 80, and then you use pair t-test to check whether or not 80 is significantly higher than 20, and then you can decide, or you can conclude whether or not PBL is effective to increase the performance. Before that, you have to check whether or not this is normally distributed, normal or not. Their graph. If it is not normal, you cannot use pair t-test. You use Wilcoxon. So statistics is very easy actually. So don't make it difficult. The most important thing is you got to understand the concept. Now this is the example. The example I mentioned just now, problem-based learning. Right? So, okay. Example 2. So I have a free gift. So I give you this book. Okay, what method should I use? This book. Who want this book? SPSS. So you can type your answer in the chat box. So the first correct answer will get this book. This one is a researcher want to find out whether learning, whether learning motivation will increase if students are exposed to gamification technique in learning. A total of 30 students in KV Shah Alam, the college vocational Shah Alam are involved. They are asked to rank their motivation level from 1 to 10. So before and after the learning session, it means that only one group. So before there's one measurement and after there's one measurement. Okay, there are some answers already. Let's take a look. We can do chi-square. Chi-square? It's not chi-square because chi-square is for relationship. We want to see the relationship. It's a Wilcoxon. Aisha. Aisha is the first correct answer. So I give this book to Aisha. Aisha MJ. Congratulations, Aisha. All right, so why we cannot use a pair t-test? Why we cannot use pair t-test? Because the data, look at the data. The data is not ratio, it's a ranking, motivation level rank, right? They ask the student to rank from 1 to 10. So what is this data? This is ordinal data. So we cannot use pair t-test. We have to use Wilcoxon. It's a non-parametric. All right. Okay, next. So if you are doing survey, you also can do this one. It's not only experimental research, and survey research also can use a pair t-test. Okay, simple regression. Simple linear regression is a method to use for to to use to determine whether or not independent variable affect the dependent variable significantly. And we also can use the model to do the projection, okay? And we also can use linear regression to identify the factor and the predictor that influence something. For example, based on the example is already here. So before that, we go to assumption. Before that, we got to understand the basic concept of dependent variable and independent variable. Okay, for example, satisfaction and income. Okay, satisfaction and income. Which one is independent and which one is dependent? Satisfaction depends on income, or income depends on your satisfaction. So usually satisfaction is influenced by income, right? So income is independent because it doesn't it is not influenced by anything. But satisfaction is influenced by your income. All right. So it depends on what depends on something. So if the variable doesn't depend, it's not influenced by anything, then it is independent. If the variable depends on something, then it is a dependent variable. All right. And another example is a teaching method and learning performance. Teaching method is dependent variable or independent variable? Teaching method is independent variable. It's because it's a method. It doesn't depend on anything. Learning performance depend on what? Depends on the teaching method. So learning performance is dependent variable. It depends on teaching method. Teaching method is independent because it doesn't depend on anything, right? Okay, so it doesn't move. All right. Okay, these are the basic assumptions. So linearity, the relationship have to be linear. Because relationship can be linear, straight line. It also can be non-linear like this. The graph, this is non-linear. It's not a straight line. So we have to check it's a straight line linearity. Okay, homoscedasticity. So there is the homogeneity of variance. All right, independent. So both variable must be independent. Normality. So it has to be normally distributed. And we could check this. We can check all this in SPSS. So how to do it? Another session, not now. Example. So the number of hours of 12 students. How big is the sample? The sample is 12 students. All right. So what is the variable? The variable is the hour of television watching. How long we watch television. And the other variable is the score of student in the test. The score and the hour of watching TV. Here is the score. So we can do the prediction. Okay, we can do the prediction. So based on the hours of span you're watching TV, we can predict your test score based on the model we produce, based on the formula, based on the equation we produce from the regression. Okay. And also at the same time, we can check actually the test score depends on hour we spend watching TV or not. We also can check using this regression, but this is a simple regression. There's only two variables. Okay, y equal this is c is a it's a constant. All right, plus x alpha here. Okay, so this is a correlation. It proves the correlation here. It's a positive or negative correlation. So if it is a positive correlation, means that it should be a negative correlation in this case, because it means that The less hour you spend watching TV, the better your test result. So it's a negative correlation. So this data here, this figure here is alpha, beta, x. X is your hour you spend watching TV. Y is your test score. So this one is your relationship, the direction of relationship. Okay. So this is the strength of your relationship. It gives you a number, for example, 0.85. So it means that the correlation is very big. It also tell you the it tell you the relation, a dominancy, whether or not this is a dominant factor that influence your test score. So this result will also tell you whether or not X is significant or not. If it is a significant, it means that hour you spend watching TV will significantly influence your test result. If the result is not significant, it means that the time you spend watching TV doesn't affect your test score. Okay, so regression is actually a very good analysis. So this is only a simple regression because only two variable X and Y. In your PhD or master, you have more than two, right? So maybe the time you spend watching TV, and then the time you spend on internet, the times you spend sleep. So these are the variable that you can put together. X1, X2, and X3. You can put together, and we don't call it simple linear regression. We call it multiple regression. So multiple regression is a very powerful analysis tools to help you to answer your to achieve your research question. And the last one is multivariate analysis. Multivariate analysis is the highest level analysis. So usually master and PhD by research will do this one. It's not master by coursework, master by research. So we have MANOVA, ANCOVA, MANCOVA, repeated regression, and repeated ANOVA. Repeated ANOVA is here. Just now I already explained in front in univariate. It should be in multivariate. So this is parametric, and we also have a non-parametric. So because we have 20 minutes left, so I have to do it very quickly. Well, right, for example, ANOVA. So ANOVA is like this. You have three groups, okay? So we have one variable. So let's say motivation. Motivation. Is there any significance between these three classes, class A, class B, and class 3, in terms of motivation? So this is ANOVA. All right. But sometimes we have more than motivation. We have motivation. At the same time, we have what? Achievement, test achievement. Test achievement. And we also have learning style. Learning style. So we have three variables. I want to see the difference, okay, with the influence of these three. So we have to use MANOVA, multivariate analysis of variance, okay, because we have multiple variable here. We still have three groups, A, B, and C. School A, School B, and School C. But we have more variable now, so we have to use MANOVA, right? So but some students ask, can I do it differently? I use ABC, I use ANOVA, I check learning style, and then I use ANOVA, I check motivation, and then I use now ANOVA, I analyze the achievement. I do it separately, not in one shot. You can do it, but you can do it, of course, but it's not accurate. Why it is not accurate? Okay, let me explain to you why it is not accurate. I give you one analogy. Example, this is example. My relationship with my father. Okay, so when I see my father, I always argue. I always quarrel with my father. This is example. Actually, I'm very close with my father. So this is one example. So when I see my father, I always quarrel. I have problem with my father. Okay. So when my mother beside me, my relationship with my father is better because I want to take care of the feeling of my mother. So in front of my mother, my relationship with my father is okay, it's good. Without my mother, my relationship with my father is bad, always quarrel. Okay. If my brother is beside me, my relationship with my father also better. Why? Because I'm the eldest brother, so I want to show a role model to my little brother. So what does it mean? So when there is other variable beside me, the relationship with my father becomes different compared with me alone. You got the idea? So it means that if you do the, if you analyze the difference in terms of motivation alone, the result might be different when there are other variable analyzed together. Okay, so if you analyze it differently, you analyze motivation differently, you do ANOVA, and then you check achievement, and then you check learning performance, your result might be significant difference, might be different significantly. But when you combine together, the result might be different. The result might be not significant because the variable influence each other. Like the example I give you, when my mother and brother around me, my relationship with my father will become different because I want to take care of the feelings of my mother and my brother also, right? So the same concept here. So that's why if you have a lot of variable, okay, you have to use MANOVA, not ANCOVA. Okay, example here. Okay, you want to determine parents' education affects student motivation and learning performance or not. So the independent variable is school level, not school level, parents' education, right? Parents' education. So some parents are school level, only school qualification, and some have a cert and diploma, and some have degree, and some master and PhD. So we have 4 group, right? So 4 group, we can use ANOVA, okay, but we have 2 dependent variable, motivation and performance. So ANOVA is not appropriate anymore. So we have to use MANOVA. Why MANOVA? Because more than 1 variable in a dependent variable. And of course, there are many requirements you have to check when you do MANOVA. Okay, so for ANCOVA, you only check reliability, right? Reliability and the normality, reliability. You have to check normality and the homogeneity of variance. But if you do MANOVA, there are many things you have to check. Collinearity, linearity, homosyntheticity, everything you got to check. Okay, and you have to remove the outlier also, univariate outlier and multivariate outlier. All right, so, but anything can be done in SPSS, no worry. So MANOVA is not that difficult actually. So, and then we also have ANCOVA. What's ANCOVA? ANCOVA is you want to check the difference between 2 groups, 2 or 3 groups, okay? But you want to control the variable that influence the variable that you want to check. For example, now I have 2 groups. Okay, I have groups, group A and group B. So I use PBL, right, in teaching. So, and then how to check the effectiveness of PBL? I check the test result. Okay, group A, I do the test, and group B, I also do the test. I compare 2 groups whether or not which group is better than which group. So group A, we use PBL. Group B, we don't use PBL. No PBL. No PBL. So if PBL, the test score is higher than group B without PBL. So of course, PBL is better than no PBL, right? Because the test result is higher. So it depends on the test result. So this one, we can use 2 group. What we use? ANOVA or t-test. We can use independent t-test because only 2 group, right? But the test result also influenced by, because just now we do pre-test also. Before PBL, we do the test already. We want to check whether or not there is a grade increment. So before class, before lecture, So we do the test and the score is only 20. And then we can see whether there is an increment, and then we compare two groups also, right? So many tests we can do. So when the student already take the pre-test, so when they take it in post-test, another test, the result tend to be higher. Why? Because they already have experience in answering the test. So this test will influence the post-test result. This is what we call pre-test. Pre-test means the test we do before the experiment. So this is called, we call post-test. Post-test is the test we do after the experiment, after we do the teaching. Okay, so pre-test influence post-test because it provides experience for the student to answer the test, right? So it tends to be higher. So it means that the marks will influence. So I want to control these marks. I want to control. So I can use UNCOVA because pre-test is the covariate. Covariate will influence our dependent variable. Okay, our test result. So we want to control. If we want to control, then we got to use UNCOVA. I give you one example. Okay, this is the experimental research. Experimental research. So there's three group here. So one is using different teaching aids, and one is using printed material in the class. This is teaching material. So one they don't use second group use electronic material, and the third one they use multimedia material for teaching. So which one is better? So O1 is pre-test before the experiment, before the class, we already have the measurement. It's a pre-test, so the result usually is very low. So this one is 21 mean score, this one is 25, this one is 19, for example. So after the test, this one is 80, this one is 85, that's why this one is 60. All right, so we can do the, but this result, O1 will influence O2. I want to make comparison between these three groups. So I can use ANOVA, basically, right? ANOVA we can use, but because I want to control this one, this is covariate, because this result will, this post-test will influence, this pre-test will influence the post-test, because it gives experience for the student to answer the test. So in the second test, it will score better. So if I want to control the covariate, this is called covariate. So I don't use ANOVA. I have to change it to UNCOVA. Analysis of covariate. So your result will be more accurate. It only shows the level of your PhD or your master. This is not, if you use ANOVA for this case, it's a degree level. It's not up to your level. I give you another example. So you want to do a research focus on the different perceptions of KV between vocational college. KV means a vocational college for international students, for your information. So the society do not have a good perception towards a vocational college. So is there any significant difference between the people living in urban and the people living in rural area? So the urban and rural citizen, is there any significant difference of perception towards KV? Okay, so this one, how many groups are here? Two groups, right? Urban and rural. What's the variable? The variable is the perception on TVET. The perception on KV, vocational colleges. So we can use an independent t-test for this case, basically. Independent t-test, because two group, not three group. Three group we use ANOVA, two group we use independent t-test, all right? But we also know that this perception will be influenced by the working experience of the respondent and the education level, correct or not? Maybe those who are living in rural area, if they have PhD, so maybe the perception is different compared with those who has only a primary school education, who are living in urban. So the level of education, maybe the years of working experience will influence their perception also. So I want to control this one. I don't want this to influence my result. So I can use UNCOVA. Okay, so UNCOVA is used, you want to control some variable that will influence your result. Okay, and you don't want the variable influence it. Okay, so you use UNCOVA. It's a control analysis. And then we have Mankova. So Mankova and Ankova is almost the same. I give you an example. This one is perception, right? How many variable? Only one, right? But maybe you have more than one variable in terms of perception, and then maybe perception of KV, and also what else? Perception and likeliness, whether they like KV or not. So two variable. So if two variable, then we use a Mankova. Okay. So example. So if you want to determine whether or not teaching style affect student critical thinking and performance in learning mathematics. Okay, teaching style. How many teaching style that we have? We have auditory style, we have dedicated style, we have facilitator style, and we have demonstrator style. We have 4 style here. How many groups? We have 4 groups here, right? 4 groups. What you want to see? What's the variable, dependent variable? Dependent variable is critical thinking. One, and the other variable is performance. All right. So for this case, you cannot use Ankova. Why? Because Ankova only for one variable, but there is 2 dependent variables. So you have to use Mankova. It's multivariate. What is the covariate? What is the variable that influence your result? The covariate can be student motivation. Sometimes, okay, whatever the learning style is, if the student are not motivated to learn, their performance is not good. If the student are not motivated, their critical thinking is not good, right? So this will influence your result, but you don't want it to influence. In reality, it will influence, but in your experiment, you don't want it to influence, then you want to control it, then you use Mankova. Okay, so Mankova is very common analysis in your survey also, in your PhD or master. All right, so this one also, you want to determine whether or not the MTUN graduate working in different region differ in terms of salary, working hour, and living expenses. MTUN, we have 4 MTUN university, right? Okay, so whether or not these graduate working in different region has differences in terms of salary, working hour, and living expenses. So I have 3, in my research, I focus on 3 region, Johor, Selangor, and Penang. So 3 group, right? Okay, the dependent variable, there are 3 dependent variables. Salary, is there any different in terms of salary, in terms of working hour, in terms of living expenses? Okay, so salary, working hour, and living expenses might be influenced by age. How old are them? If they are 40 years old, maybe the salary is higher. Why? Because their working experience is higher. So marital status, if they are married, so maybe the living expenses will be higher. So these 2 variables will influence the dependent variable. But in my research, I don't want this variable influence my result. I want to control. So what you use Mankova. Is that simple? That's very simple, right? So how do I know whether or not age and marital status influence the salary and the living expenses? How do I know? It is from literature review. You have to read, right? You have to do the literature review to see all these things. All right, so what else? Multiple regression. Multiple regression is very, very powerful. So it's different from a simple regression. So simple regression, only one dependent variable and one independent variable. And this one is multiple dependent variable. Multiple independent variable. So this is the model of regression, example model of regression. So if you do the analysis, you can check there is your independent variable, father education, mother education, and your grade in high school, and your gender. Okay, so whether or not it influences mathematical achievement. Mathematical achievement depends on gender or not. So we can check, is it significant? Oh yes, it is significant. Maybe female score better than male. So your grade in high school. So this is in university. Your grade in high school, whether or not it influence. So you check. Oh yeah, it's very significant because this number of is smaller than 0.05, so it's significant. Your father and mother education influence your mathematics achievement? Not. Based on this result, it's not significant. So you throw away. This is not significant. You throw away. You have only grade in high school and also gender. So based on this result, which one so based on this multiple regression, you already identified the factor that influence your result, that influence the mathematics achievement. Original, you have 4, right? Father education, mother education, grade in high school, and your gender. So after you do the analysis, you only find out there are 2 factors only affect mathematics achievement test. Okay. So based on these 2, which one is more dominant? So you see this one is 0.456 and the other one is 0.29. So of course, grade in high school is the most dominant one. So in your research, this is very common because in your research, you usually find out, right, what are the factors influence blah, 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 blah. What are the factors influence skill acquisition? What are the factors influence technical skill? What are the factors influence job satisfaction? So you have many, based on literature review, you have many factors, okay? But which factor is significant and which factor is dominant? So you can check using regression model or multiple regression. This is the example for multiple regression to determine the factor that significantly influence job satisfaction among academic staff in polytechnic. All right, job satisfaction is your dependent variable because this variable depends on the factor, on your salary, workload, and blah, 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 blah. How many independent variable you have? You have salary because salary influence job satisfaction. You have workload, you have working environment, co-worker relationship, management, and leadership. Okay, so in this case, you can use multiple regression because it will tell you which factor is significant. So maybe working environment is not one of the factor. We don't know, right? So you have to do the multiple regression. Then only it will tell you which factor are significant and which factor are dominant. Right? So this is also what's this? Okay. So it doesn't matter whether it is regression. We have a lot of regression types of regression. We have multiple regression. This is the common one I tell you. We have a group-wise regression. We have a hierarchical regression, and we have binary regression. Okay, and every regression analysis here depends on the case you want to analyze. All right. So job satisfaction. So this is the first case. This one you use multiple regression. Now we have second case. All right, so we want to study about job satisfaction. All right, and the factor that influence job satisfaction in terms of salary, workload, and so on. But I want to see whether or not these factors are different in terms of male and female, and in terms of Malay, Chinese, and Indian, in terms of race. Are they different? So maybe for male, salary is one of the factor, but maybe for female, salary is not one of the factor. Maybe for male, working environment is not a factor for job satisfaction, but maybe it is a factor for female. All right. So I want to see whether or not these grouping variable are different. Okay, in terms of factor that affect job satisfaction and also based on race. So if you want to look in this aspect, you can use group-wise linear regression. It's a multiple regression, but it's a group-wise. So the result will give you the result in terms of male, female, Malay, Chinese, and Indian. All right. So this is a very, very good analysis for your PhD, actually. So someone saying something? Okay, about mediator and moderator. Okay. Kita ada beberapa berapa minit saja. So I still have a few slides. Shall I stop here or what is your opinion?
We have few minutes left, Doctor. I think it's okay. Is it still a lot?
Sorry.
Or how many minutes you can manage to
Let me check
complete?
how many slides left. Maybe 4 slides, 5 slides. I can make it very quickly.
Yeah, sure, Doctor. You can finish it.
Okay. All right. So please bear with me. All right. So the third case is that you want to check also. Okay, the same thing, job satisfaction and also the salary, the factor. But at the same time, well, you know that it also, apart from this major variable, and you found out that the demographic data or the demographic factor also influence the job satisfaction. For example, the marital status, their education level, and their job position, whether they are manager or technician or operator. So this demographic factor also influence job satisfaction. So you want to add this factor. So what analysis can you do? This is the main one. The IV is the main one, your original factor. But you found out that demographic factor also influence job satisfaction. You want to add. So we can use hierarchical regression analysis. So the first one is first hierarchy and the second one is second hierarchy. Okay, so, and this one is binary, job satisfaction. So it's the same with the multiple regression. The only difference is that for multiple regression, this one is multiple linear regression. This one is interval and ratio data, job satisfaction. Let's say you change it to high and low satisfaction. It's a dichotomous data. Only two, binary. Two answer only, high satisfaction or low satisfaction. That is your data. You key in SPSS as high and low satisfaction. So then you have to use binary logistic regression. Okay, so binary logistic regression is based on your the type of data that you have for DV. Okay, dependent variable. So, and we also have non-linear regression. What I explained just now is a linear regression. So sometimes after we check the linearity of our data, it's not linear. So what can we do? We can use a non-linear regression. So this is linear regression. You can see the straight line here, right? But this is non-linear. You see the regression, the relationship is a curve. And this one also non-linear. You see, it's like that. So if it is non-linear, you have to use non-linear regression. So how do I know? We check this one. You're using the scatter plot and the residual plot. And how to do this? In SPSS. Very easy only. Okay, this is the general, a simple summary of data analysis that we have. You can refer to this one. So now this one is not for nominal or ordinal data. This one is for interval and ratio data. And then you have to check the normality. It is normal or not. If it is normal, and then you go through this way. If it is not normal, you go through this way. All right, and then CPA and CFA, and this is also majority of the PhD student will do, because this one will help you to check your questionnaires construct validity. All right, CPA and CFA, PCA is principal component analysis. CFA is confirmatory factor analysis. The step is the same in SPSS. The procedure is exactly the same. Okay, so PCA is used for, okay, let's show you the example. This is for PCA. So you have many variables, right? Teaching satisfaction, job satisfaction, leadership, blah, 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 blah. All right. But because you have nine variables, it's too many. So you want to reduce the variable, the dimension. So, but how do you reduce it? You don't know, right? So you can do the PCA to help you to reduce the variable. For example, based on the CPA, you see the loading here. This one is factor loading. The factor loading loaded in the factor 1 for teaching satisfaction and job satisfaction. It means that these two variables can be combined, become one factor. Okay. Now leadership and management can be combined in factor 2. Training opportunity and career development can be combined in factor 3, and these 3 can be combined in factor 4. So from 9 variable, you reduce it to 4 variable. Okay, so this can be done using PCA, Principal Component Analysis. Okay, it helps you to reduce your variable. And we also have CFA. CFA is for your questionnaire. So let's say you have many variable here. This is, what is this? Teaching, good teaching. CGS is CGS, clear goal. AWS, workload. Okay, you have many items here, right? Many items. Originally, you have admin item. After you do the CFA, some item will move to here. Some items, some GTS item will move to QSS because you do it wrongly. You don't design your item correctly. So when you do the CFA, it will move around. So the item will move here and there. So this is the final outcome. So in the CGS originally, you have 10 items. So after you do the CFA, it become how many items? 6 items only. Okay, it helps you to adjust. This item means that this item really measures GTS, and only 4 items measure CGS, and only 2 items measure the AWS. 2 items cannot accept because minimum is 3 items. Minimum 3 items. So you have to add more items and then do your pilot test again. If you don't want, you want to save time, you just delete this one. Don't take it, delete. Okay. So this is help you to identify your construct validity. So the procedure for CFA and PCA is the same, but the objective is different. The purpose is different, but the procedure is the same. We also have EFA. EFA and CFA is more or less the same. It depends on when you use it. Okay, this is the PhD research objective that I analyzed. I was the external examiner for this one. Okay, so because I copy directly from the thesis, so it's in Bahasa Malaysia. So for the first one, mengenai pasti kesediaan guru dalam pelaksanaan pengajaran RBK tahun 4. Okay, what statistic you want to use? This one is to identify the readiness of teacher in teaching RBT. Anybody? Okay, the first and second is the same, right? First and second is the same. Mengenai pasti kesediaan guru dalam pelaksanaan pengajaran RBT. Yang kedua adalah mengenai pasti efficacy, motivasi, bla bla bla. So apakah cara yang awak nak guna? So one box here, one. Ini slide yang last kali. In your opinion, what should you use? Ada jawapan. So, untuk objektif 1 dan 2, kita nak tengok apa? Okey, betul descriptive statistik, tapi jawapannya tak tepat. Apa descriptive statistik itu betul lah, tapi apakah tekniknya? Yes, exactly. Who is that? Is that how to pronounce your name? Clarice or Clarice? So we use mean and standard deviation, mean. You just find out the mean. Apakah kesediaan? Tengoklah mean dia kan. So berdasarkan mean awal lah tentukan dia punya tahap tinggi ke rendah. Begitu juga dengan efficacy and lain-lain. So we use mean, So and congratulations, you got this book, Clarice. Okay, number 3, to identify the difference. Number 3, to identify the difference, kesediaan, the readiness, the teacher readiness, the difference of teacher readiness in the aspect of gender and teaching experience. Okay, correct. Anova, I give you this book. Okay, Chan also correct. T-test. Okay. T-test is for gender, right? Because two group teaching experience is what? Teaching experience because more than two groups. Alright, so the next one is apakah kesan jantina dan kategori sekolah terhadap pengetahuan dan kemahiran? In your opinion? Multiple regression. Okay, now multiple regression tak tengok ni, tak tengok perbezaan. Chi-square pun tak tengok perbezaan juga. Dia tengok ni kan, hubungan. Regression pun hubungan juga. Atau menentukan faktor. Yang ni apa dia? Menentukan kesan. Apakah kesan, menentukan kesan jantina kategori sekolah. Kategori sekolah contohnya sekolah luar panda dan sekolah panda. Jantina terhadap pengetahuan. Kategori sekolah ada 3 kategori. So, ada ke jawapan? Independent sample, MONOVA. Oh, ni kaedah baru ni, MONOVA. MANOVA salah eja. Alright, so okay, jawapannya adalah MANOVA. So yang betul adalah Nur Hidayah Hamdan. Nur Hidayah Hamdan ni Dr. Hidayah ke?
I think so. Betul.
Okay.
Betul Hidayah.
Tak apa, Dr. Hidayah pun dapat juga. So jawapannya adalah sebab ada berapa variable dekat sini. Variable ni ada 2 kan. Group ada berapa? Ada group ada dia tengok jantina lelaki perempuan. So variable dia berapa? Variable dia ada more than one, right? Pengetahuan, penakor dan kemahiran PBS. So we can use MANOVA. So next, menentukan hubungan antara bla 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 bla. So nak guna apa ni? Okay, so semua dah betul, correlation. So the first answer will be siapa yang first
The first answer is from Chan Tak Ji, independent sample. After that, Zakia with correlation.
The first one is Chan Tak Ji.
Is it correct, or the correlation is the correct answer?
Alright. Okay, so the last one, special sikit sebab buku ni. This is a very this book. I give you this book. Statistics for Educational Research. So the last one is menentukan faktor yang menyumbang kepada kesediaan guru dalam melaksanakan pengajaran RBT. So let's see who get the first correct answer. Multiple regression should be the answer. So siapa yang first? Laju sangat. Multiple regression. Chan Tak Ji juga ke?
Yes, I think so. The second one is Zakia Habib.
Huh?
The second answer is Zakia Habib, multiple regression also.
All right, so good. All right, so basically that is the end of my talk for data analysis. So thank you very much. So we already over the time, beyond the schedule already.
It's okay. So thank you, Dr. Lai, for the amazing sharing. So even though we are over the time, so there's few questions from the audience. Maybe the first one is actually from the introduction, I think. There's a question saying, from Azhani, is that possible if all the questions in our questionnaire set are in nominal data?
Can you repeat the question?
Is that possible if all the questions in our questionnaire set are in nominal data?
Oh yes, it's very common that we have ordinal data, right? So usually apart from demographic data, usually our items are composed of ordinal 1, 2, 3, 4, 5, right? Or 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So this is the ordinal data. But when we do analysis, we don't use this data. When we do analysis, we calculate the mean. For example, my questionnaire has 5 variables: learning style, visual, auditory, and kinesthetic. Visual, I have 5 items. We have 5 questions for visual. So 5 items, each item is composed of ordinal scale. So this 5 item, I will calculate its mean to represent visual style, visual learning style. And then we also have 5 items for auditory. We also have 5 items for kinesthetic, right? Every item it becomes an interval already.
Okay.
So although our item is ordinal in scale, the scale of measurement is ordinal, but if we calculate the mean value will convert, the ordinal will convert to interval because we use mean value to do the analysis.
Oh, okay. I hope Mr. Azhani can it answered your question. Okay, so next one is when the next question is, what about mediator and moderator variable? Sorry.
Okay, so mediator and is very common also nowadays to check the mediator and moderator in a PhD and master research. So mediator means a variable that influence the relation, that cause the relationship to happen. For example, I want to check whether or not there is a relationship between achievement and the time you spend in library. Is there a correlation? So based on your analysis, you find out there is a correlation. The time you spend in library and your academic achievement has a positive relationship, but there is a mediator effect. Is a mediator between the time you spend in library and the academic achievement. Sometimes, why? Because the time you spend in library might be you just spend the time for chatting, surfing the Facebook. So it's not helpful for your academic achievement. So the mediator will be the material that you read. Material that you read is the mediator for the relationship between the time you spend in library and academic achievement. Okay. So from the relationship, you can see, okay, the time you spend in library has a positive relationship with the achievement. But in reality, the time you spend in library doesn't affect your academic stuff if you don't spend your time in reading the books related to the subject, right? If you spend your time in library watching video, surfing Facebook, will it help you to increase your academic achievement? No, it won't. So there is a mediator. The mediator might be the material that you read in the library. Okay, so you want to set the effect. You want to find out the effect. So whether or not the material that the material you read in library really mediator or provide mediator effect in the relationship between time spent in library and academic achievement. So how do you find out? You can use a mediator analysis. And where can I do it? You can do it using SEM, sequential equation modeling. And SEM is a very powerful, it's a modern analysis. So most of the students are doing SEM now. And also moderating effect. Moderating is, for example, the time you spend in library and the academic achievement, but maybe it depends, it will be affected by the gender. Maybe if females spend more time in library, it will study hard. Maybe for male student, if they spend time in library, they will sleep in the library. They spend more time to sleep in the library. So maybe the relationship is influenced by gender, right? But that is your hypothesis. Do you have to confirm whether or not gender is a moderating variable or gender provide moderating effect? So you can do it using moderating analysis through SEM also. And you, apart from SEM, because SEM is quite complicated, right? You can also use regression actually to check moderating and mediating effect. In SPSS, you have a GLM, right? Generalized linear model. So you can do it through that model.
Okay, so I hope that would answer the question just now, Mr. Rijal. Okay, so the last one is from Mr. Jauhari. So he asked how to check multivariable correlation for non-parametric statistical analysis. So what methods is suitable and assume not normally distributed data and non-linear multivariable regression problem.
Again, please.
Okay, first one is how to check multivariable correlation for non-parametric statistical analysis.
Okay, multiple correlation, right?
So what is the method suitable for it?
You can use multiple correlation analysis in SPSS.
So here he noted that assume not normally distributed data and non-linear multivariable regression problem.
Assume that it's not normal distribution. If there's no normal distribution, you cannot check the correlation already.
Okay. Okay, so that is the answer, Mr. Jauhari. I hope it answered the question just now. All right, so we are almost end. So
you mean two variable, is it? Wait. You mean you want the linearity or the correlation between two variable? Which
I'm not sure. Maybe Mr. Jauhari, you can just open your mic and then maybe explain the question again. Is there Mr. Jauhari here?
Yes, I'm here.
Yes.
So for example, I have a nonlinear regression problem with a variable more than 2. So I want to check the variable relationship of the variables.
Okay, so it means that you want to check the correlation, right? But
yes,
the variable is not normally distributed.
Yes.
Yeah, you can use Spearman.
Okay.
Yeah. So if it is normally distributed variable, you can check using Pearson. If it is not normally distributed, you can use a Spearman correlation.
Thank you.
All right. Thank you for the overview for us. Okay. So thank you again, Dr. Lai, for sharing his valuable insight, and thank you everyone for attending today's sharing.